Welcome to qnawire.
To determine whether or not a molecule is polar or nonpolar, you first need to draw the Lewis structure, and then from the Lewis structure, determine whether or not it has polar bonds and whether or not those polar bonds cancel due to the geometry of the molecule. The first one is silicon tetrachloride. It has 32 valence electrons, giving the silicon an octet with the 4 bonds that it has to the 4 chlorine atoms. This is a tetrahedral structure because all of the bonds are exactly the same. They're all chlorine silicon bonds. Although each bond is polar, the molecule itself is nonpolar due to the symmetrical geometry of the tetrahedral structure. The next one is CF2Cl2. When drawing the Lewis structure, we'll see that it also is tetrahedral, but the bonds are not the same. 2 of them are CF and 2 of them are Cl. Although the molecule looks planar, suggesting maybe these 2 bond polarities would cancel, and these 2 bond polarities would cancel, that is not the case because the tetrahedral structure is not planar. So this would be a polar molecule. The previous one is nonpolar. The next one is selenium hexafluoride. There are 48 valence electrons, giving all fluorines an octet and selenium an expanded octet. This is an octahedral structure, and an octahedral structure with all 6 bonds being the same is nonpolar, allowing for bond polarity cancellation, making the molecule nonpolar. And the last one is IF5. When we draw the Lewis structure, there are 42 valence electrons. We'll use up 40 of them, bonding the 5 fluorines to iodine and giving each iodine an octet. We have 2 additional valence electrons that serve as a lone pair on iodine. This is an octahedral electron group geometry, but because one of them is a lone pair, it ends up being a square pyramidal structure, which is polar due to the presence of the lone pair.